Hi, we're going to do the Day 5 notes today. So please open your packets to the Day 5 notes, and we're actually going to start on the back of the first page where it says Day 5 notes. Please find your page where it says Key Features of Functions, Review Terms. These are the terms, these are the topics that you covered back in Algebra 1 2 years ago, so we're going to do a quick review of them, and then we're also going to learn a couple more features, key features of functions. First one is the y-intercept, where it crosses the y-axis, where the value of x is equal to 0. So this is where a graph will cross the y-axis. We have the x-intercept, where the function crosses the x-axis, also called zeros roots. The value of y is equal to 0 because it doesn't have height. Then we have increasing. The function is increasing when the graph is rising. As you move from left to right, remember when we're talking about a function, we're always looking at it from left to right, just like we're reading a book or we're writing from left to right. So as x values are increasing, the y values are also increasing. Decreasing is also when you move from left to right, the graph is falling. So as x values are increasing, then the y values are decreasing. So a graph looks like this. For the increasing, as x values are increasing, and the function is increasing. Constant, as you move from left to right again, but the graph stays flat, it's horizontal. So a graph that's constant will have a horizontal line somewhere in there. The y values stay the same. Positive is the interval for which the graph lies above the x-axis. We covered this in the previous chapter. So y values are positive. They're going to be above the x-axis. Function f of x is less than 0 is the x interval for which the graph lies below the x-axis, and the y values are negative, so they're below the x-axis. Another word for x-intercepts is called zeros, which is also called the roots. So again, it's where the graph crosses the x-axis. So roots, zeros, x-intercepts, they all mean the same thing. Absolute maximum or minimum is the x value where the highest or lowest point occurs on the graph. And then the relative maximum or minimum is more like the local, where in that area there's a turning point. It doesn't necessarily mean it's the highest or the lowest. It is some turning point in the graph. We call those also peaks or valleys. In Algebra 1, you also talked about left and right end behavior, the directions that the ends of the graph point to, whether we're going to positive infinity if we're going up, or we're going to negative infinity if the arrow is pointing down. The new features of a function are the first two, continuous and discontinuous. A function is continuous if it doesn't have any breaks in the graph. So an example would be something that looks like this. That's a continuous graph. It doesn't have any breaks. You don't have to lift your pencil up from the paper to graph it. If a graph does have a break, it is called discontinuous. You've seen these already in Algebra 1. They're called the piecewise functions, where we have pieces of graphs put together. But there's a break, you have to lift your pencil up in order to go from one graph to the next. Step functions also is another example of discontinuous graphs. It's called the step function because they look like steps. Another feature of functions, we can categorize them as either even or odd functions. Functions that are even means that they have symmetry with respect to the y-axis. And a picture, an example of that would be a handy-dandy absolute value graph. That when you reflect it over the y-axis, it's the same picture as the original. Odd functions also have symmetry, but with respect to the origin. A way to remember that odd functions have symmetry with respect to origin is the fact that odd starts with the letter O and origin starts with the letter O. So origin, odd. Odd functions have symmetry with respect to origin. An example of that would look something like this, where we have a constant, then it turns into a linear, and it goes back to a constant. should cross at the origin right there. So there's an example of graph that has symmetry with respect to the origin. Let's go back to the front of our notes, and let's do an example. This should look a lot like what you did back in Algebra 1. We have the function y is equal to f of x is shown graph to the right. We're going to answer a whole bunch of questions about it. First of all, state the y-intercept of the function. Look at the graph. The y-intercept is at 2. And just a reminder, that's when x is equal to 0. Letter B is asking for us to state the x-intercepts. And the x-intercepts is where it crosses the x-axis. We have 2 of them here. And let's count them: -1, -2, 3, 4, 5, -6. And the other one, 1, 2, 3, 4. X equals +4. As you know, we have other names that also represent the x-intercept. They're also called the roots. The graphing calculator calls them the zeros. X-intercepts, either way, it's when y is equal to 0. Next question is asking us to determine, is the function increasing or decreasing over the interval from -1 to 2? Notice we're using the x values to determine, to find as the interval. So from x equals -1 to 2, and because we read our graph from left to right, we're going from left to right, we notice that the y values are increasing. Therefore, the function is increasing over the interval -1 to 2. Letter D is asking for us to give the interval over which f of x is greater than 0. What is a quick way of seeing this visually? We look to see where does it lie above the x-axis. And again, we did this last chapter. Where is it above the x-axis? And again, we can trace or highlight it. We're above the x-axis from one x-intercept to the other x-intercept. So between -6 and 4. Notice we're not including -6 and 4 because we're not asking where f of x is also equal to 0. There is no equal sign there, so we can't include -6 and 4. This is the set notation method of writing the interval from -6 to 4. We could also use interval notation to show the interval from -6 to 4. And again, using the parentheses instead of the square brackets. Make sure -6 and 4 are not included. Letter E, state all the x-coordinates of the relative maximums and relative minimums. We're going to state all, let's cross out the x-coordinate, state all of the relative maximum minimums, because I want to make sure we state them as the coordinate pair, not just the x values. We want to make sure we get both the x and the y. So the relative maximums are going to be all the peaks. And we have a peak here and a peak there. So it's in 1, 2, 3, 4, -4, comma 6 is a maximum, and there's another maximum at 2, 1, 2, 3, 4, 5, 6, 7, 8, at 2, 8. So both 2, 8 and -4, 6 are the relative maximums. And when we look at the graph, there are 3 relative minimums. There's one out here, there's a valley up there, and there's a valley here. So again, we call them peaks and valleys. So we have 3 relative minimums. The one that's furthest left, count the boxes, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, -8, -4. And the one in the middle, count the boxes, -1, 1. And the last one on the right-hand side, that minimum, 1, 2, 3, 4, 5, 6, 1. Oh no, sorry, 6, 2. 6, comma 2. Now the next question, letter F, is asking for the absolute maximum and minimum. And where do they occur? So from the relative max and the relative min, we will have the absolute maximum and the absolute minimum. So the absolute maximum, which one of those 2 points is the highest point, And again, we're looking at the y value. We're comparing which one has the highest y value, which in this case is 2, 8. And the absolute minimum, which of those 3 points has the absolute lowest y value? And that's going to be the -8, -4. We want to make sure we get in the habit of writing these answers as points, not as just specific either x values or y values, unless the directions specifically ask for the x or the y. So for now, I want to make sure we are writing them as the particular coordinates. State the domain and range of f of x using interval notation. Domain, the furthest left that we go is from -8 to 6, including -8 and 6 because we have closed endpoints on the graph. Now, what's interesting about the range, if we look at our absolute minimum and absolute maximum, our range is right there. The lowest y value is -4, where the highest y value is 8. So the range, we can confirm that on the graph, goes from -4 up to +8. Last question on the bottom. If a second function g of x is defined by g of x is equal to 1/2 x plus 2, then what is the y-intercept of g? To find the y-intercept, we let x equal 0. So the corresponding y value, 0 plus 2 is 2. 1/2 of 2 is 1. Y-intercept y is equal to 1. All right, so far all that's been reviewed. The next page, we'll talk about the symmetry. Symmetry can be used to help sketch the graphs because we only need half the points, just like with parabolas. Symmetry can occur within the y-axis, x-axis, or origin. However, since an equation that is symmetric with the x-axis is not a function, let's take, for example, the sleeping parabola, we're not going to be talking about symmetry with respect to the x-axis. We're just going to be talking about symmetry with respect to the y-axis or symmetry with respect to the origin. Because again, any relation that is symmetric with the x-axis is not a function. So we have a test to determine whether or not a function is even or odd. To determine if a function is even, we replace the x value with a -x, and we should get the same y value. You've seen this before back in geometry. There was a rule that when you reflected a point over the y-axis, xy became -x, comma y. That should look really familiar. So a really quick example was something you may have done last year is if we have a point out here, let's say 4, 2, and if we reflect that point over the y-axis to this side, we have the point -4, 2. So it's a reflection over the y-axis. When the x is negated, you still get the same y value. The test to determine if a function is odd, we replace the x with a -x, and you get the negation of the y value. And that should also sound familiar because you reflected points over through the origin. And when you took a point x, y, and you reflected it over the origin, we negated both the x and the y value. So a -x, -y. So there's 3 different ways we can do these tests depending on how our function is given. Questions 1, 2, 3, our functions are given as a graph. In question 4, our function is given as a table of values. And in question 5, our function is given as a mapping. So each one's just a little bit different, but we're applying the same test to determine if the function is even or odd. In number 1, we're going to observe to see if it has any symmetry, if it has symmetry with respect to the y-axis or symmetric with respect to the origin. And we say, yes, we have symmetry with respect to the y-axis because of its shape. This is even because it is symmetric to the y-axis. Number 2, ask the same question. Does it have symmetry? Is it symmetric with respect to the y-axis? Is it symmetric with respect to the origin? Both of those questions say no. Therefore, it is neither. It doesn't have any symmetry. And that's okay. Functions don't have to have symmetry. Number 3, does it have symmetry? Yes, it does look like it has some symmetry. If we kind of look at the points, we see this point, maybe it's a 2, 1. If it gets reflected through the origin, comes out the other end, to now a -2, -1. Therefore, it appears to be an odd function because it is symmetric to the origin. The second way they can ask you a question about even and odd is by giving you a table of values. So here we have x and h of x. Don't forget h of x does represent the corresponding y values. So we're going to ask ourselves, do we have both positive x and positive y, and we have a negative x and the same y value? Or do we have x and y and the negation of both of them, negative x and negative y? So which one of these scenarios, if we either one of them, we may not have either one of them, do we have? So let's look at a couple of points. We have negative 3 comma negative 15, it's on the graph, and we have a positive 3, positive 15. Let's look at another one, see if we can find a pattern. Usually try to stay away from zeros because zeros are hard to negate to see if they're actually negated. Let's look at another point. We have negative 1 comma 3, that's on the graph, and we have the point 1 comma negative 3. Do you see a pattern? Is it just the x value that's negated, or are they both negated? Hopefully you're saying to yourself that they're both negated. So since they're both negated, that means that it is an odd function. So it's another way that we could ask you to determine if a function is odd, even, or neither, by giving you a table of values. So again, by observation, observe if points, which points are on the graph. Do they represent a reflection over the y-axis, or is it a reflection to the origin? Another way that we could ask you an odd, even, neither question is by giving a mapping. So let's list out some coordinates. Let's just list out some points that are in this mapping. And again, to review what a mapping is, the domain values are always in the left circle, and the range values are always in the right circle. So we have a point 1 comma 4 that's in this function, and we also have the point negative 1 comma 4. What else do we have? We have a 3 that maps onto 8, is a point in this function, and we have another point negative 3, 8 that is in this function. So again, just by observing, we see that the x value is negated, but the y value stays the same, so we can conclude that this function is even. On the next 2 pages, 3 pages, we have a classwork. You can either take your own time right now to do the classwork, check back with the video with your answers, or you can just let the video run and we'll do the worksheet together. So however you would like to do it. If you want to do it on your own, come back, just press pause, and you can come back to it. All right, key features of functions. For each of these 3 functions, we're going to do several things. We're going to determine the domain and range, determine when they are increasing or decreasing, and if they are positive or when they are positive, negative, and describe the end behaviors, and then determine if they are even, odd, or neither. All right, we're going to use interval notation for all of these because interval notation is what we use for increasing and decreasing and positive, negative. So for domain and range, just to stay consistent, we'll continue using the interval notation. Because of the arrow tips, domain and range will be going towards infinity and negative infinity, or it's all real numbers. So the domain, negative infinity to positive infinity, and same thing for the range, negative infinity to positive infinity. And again, as soon as you see arrow tips, that gives you a clue that one of them, if not both of them, will have infinity as one of their values. Where is the function increasing? The function is increasing, again, from left to right. It's increasing from negative infinity to 2, and it's increasing again from 2 to infinity. So those are the 2 intervals where the function is increasing. Don't forget, we're using the x values to describe what the y values are doing. It is decreasing in the other interval. We can't have the same intervals be in the answer for both of these questions. It is decreasing from negative 2 to 2. I'm going to erase what I have so we can then highlight where it's positive and where it's negative. Okay, so the next two questions, positive and negative. Positive means we're going to be above the x-axis. Negative, where is the graph below? So positive, where is it above? It's above the axis from here to here, and then it's above the axis again there. So those two intervals are from -3 to 0, and then from 3 to infinity, it is also above. Where is it below? It's below here and here. Notice we're not including those we're not including the zeros. All the intervals here we're using the parentheses. It's negative from -infinity to -3, and then it's negative again from 0 to +3. Notice we're using parentheses. We're not using the square brackets because the positive and the negative are not including zeros. End behaviors on the left, they're approaching -infinity. And on the right, your y values are increasing and getting higher, and they are approaching +infinity. Make sure that we're using the positive and negative signs to indicate if it's approaching -infinity or +infinity. To determine if it's even, odd, or neither, we can look at the graph and see what symmetry we have. It's definitely not an even function, but it looks like it's odd. And we can verify that by looking at the points. We have what is -2 looks like a 10, and we can negate both of them to +2, -10, and we can see how it does. It gets reflected into the origin and then back out. So it appears that this function is an odd function. It is symmetric with respect to the origin. I would like to add one more row to this table. And then this last row is going to list the zeros of each of these three functions, meaning where does the graph cross the x-axis? Crosses the x-axis at -3, crosses the x-axis at 0, and it crosses the x-axis at +3. Okay, so far so good, I hope. Graph number 2 is a parabola. And we're going to answer the same questions. The domain, because x can go as far left as far right as we want, -infinity to +infinity. However, the range, we know that the parabola is stopping here at -4, and it can have any y values that are higher than -4. At what interval is this parabola increasing? It is increasing, again, remember, going from left to right using the x values from +1 to infinity. It's increasing, and it's going to be, and it's decreasing the other interval from -infinity up to 1. It's decreasing from the left. Where is this parabola positive? It's positive in two intervals. Let me erase this. It is positive above the x-axis here, and it's positive above the x-axis here. These are both positive y values. The ones in the middle here are negative y values there. So let's write down those intervals. It's positive from -infinity to its first x-intercept, but again, we don't include it because we're not looking for where it's equal to 0. And then the second interval where the function is positive from 3 to infinity. It is negative from -1 to 3, the interval between the two outer intervals. This is a happy parabola. That means that both left and right end behaviors, +infinity. The symmetry for this parabola, there is none. It is not symmetric with respect to the y-axis, nor is it symmetric with respect to the origin. Neither. For the zeros, I'm going to just write them in a different notation. Don't forget, we can use a set notation that the parabola crosses the x-axis at -1 and at 3, so we can use those fancy curly brackets if we want to. Make sure that you understand that means set notation. That means the x values. All right, last one of this kind. Domain and range. Arrow tips again tell us that we'll be going from -infinity to positive infinity. No restrictions on the x's nor the y's. Where is it increasing? It is increasing, see, from -2, looks like -1, and then from 0 to, looks like it's like a 0.9, 0.8. It's not quite at 1. It looks like it's at 1 and it's actually crossing the x-axis. So a little bit before 1 is when it stops increasing. And that's okay. You're going to hopefully get used to, you'll see more of that where your intervals may not be right on nice integers. So it's increasing, what do we say, from -2 to -1. And then it's increasing again from 0 to, what do we say, about 0.8, 0.9, 0.8. Nearest tenth is good. We don't need anything further out than that. Where is it decreasing? From left to right again, it's decreasing from -infinity to -2. From -1 to 0, and then from that 0.8 down to infinity. So let's write down those 3 intervals of when is it decreasing. From -infinity to -2. Notice how those endpoints are going to repeat. And then we said from -1 to 0, it's decreasing. And then it's decreasing again from 0.8 to positive infinity. Where is it positive and where is it negative? Let me erase these highlights. And positive. Positive means above. So it's above, oh, it's a very large interval where the graph is positive. There are 2 ways to say this. You want to be careful because we're not looking for where it is equal to 0, so we cannot include -2, we cannot include 0, and we cannot include 1. And we can't include 1 either, but we can include all the numbers that are between there and negative and the positive infinity on the left-hand side. I'm sorry, negative infinity on the left-hand side. But we just got to make sure we can't include those. There's 2 ways of writing that. The one way is by actually listing out the 3 separate intervals. -infinity to -2 is where it's above the x-axis. It's above the x-axis from -2 to 0. And it's also above the x-axis from 0 to -2. So that's one way of writing it. I'm going to put an or here and draw an arrow up on top because I don't have enough room there to write the answer. Or we can say that it is positive from -infinity all the way, and that should be a 1. Sorry, let me fix that. This should be a 1. So it's positive from -infinity all the way up to 1, comma, however, but not at -2, 0, or 1. So there's another way of writing that same exact interval. We can take either of these 3 intervals, 3 separate intervals here. Notice not including the -2, the 0, and the 1. We've got the parentheses instead of the square brackets. Or if you want to write it as one big interval, you may do that. Just please be careful. You have to write down that we cannot include -2, 0, 1 because that's where the function is actually equal to 0. And we're not looking for that. We're only looking for where it's positive. Negative, this one's pretty easy. There's only one section, only one interval where it's negative, and it's after the 1. So the interval will be from 1 to infinity, that the graph is negative. Left and right end behaviors. Your left behavior, we are approaching positive infinity. the right end behavior, the y values are approaching negative infinity. Like number 2, this one does not have any symmetry. And our x-intercepts, roots zeros are x equals -2, 0, and 1. All right, let's keep going. Question number 4. If j of x is the line positive 1/3 x plus 9, which statement is always true? And we're not going to use a calculator because we can definitely sketch that on our own. So here we go. Here's a grid. We know that the y-intercept is at 9. Slope, 1/3, tells us to go up 1 to the right 3, up 1 to the right 3, up 1 to the right 3, down 1 to the left 3, down 1 to the left 3, down 1 to the left 3, and connect the dots, and we get a line. So let's see which one of these 4 statements is true. Number 1 is saying, is j of x less than 0? That's not true because we're actually greater than 0 on a good portion on paper. Is j of x always positive? Is it always above the x-axis? Nope, that's not true because we do know that here it does hit the x-axis, and over on this side it is going to be less than 0. Number 3, if x is less than 0, then j of x is less than 0, the y values. Or should we say if x, so that means that all these x values here that are negative, so here x is less than 0, is it true that this entire function is also less than 0? Nope, because only part of it is. This part is still positive. Let's hope choice 4 is the right answer. When x is greater than 0 on this side, is it true that the entire function is positive? Yes, it is. It is positive entirely when x is greater than 0. All right, let's go to the back. Next page, back. There's another graph. I'm going to answer the following questions. And here we go. Letter A. Find the value of each of the following using the graph. So 2 times the value of the y when x is equal to 4. So when x is equal to 4, 1, 2, 3, 4. Corresponding y value is 1. 2 times 1 is 2. Let's see, g of 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. The y value is 1, 2, 3, -4. So we've got a -4 plus g of -1, 2. -4 plus 2 is a -2. So again, you want to make sure that you know how to get those corresponding y values when it's written like that off the graph. For how many values of x does g of x equal to 5? So 5 is the y value. 1, 2, 3, 4, 5. I've got 1 there, and I have 1 all the way over here on the left-hand side. So when y is equal to 5, I've got 3 x values. So for how many values? There are 3. Make sure you understand the directions for how many. While in the next one, it says illustrate on the graph and state the values of x where g of x is equal to 5. So we did that. We illustrated by putting a dot there where y is equal to 5. And what are the values of x? Over on the left-hand side, we can't say it is an integer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. -9, -10, -9.8, -9.9, around there. Like I said, sometimes we'll have those decimals because we don't quite have nice integers all the time for all of our questions. Where else is y is equal to 5? It's equal to 5 at x is equal to 1. And it's also equal to 5 when x is equal to 2. So make sure you're reading the directions and you know exactly what they're asking for. Letter C, what is the y-intercept? 1, 2, 3. Looks like it's y is equal to 3. Letter E is asking for the absolute minimum and maximum points the graph obtains. So it's the highest peak and the lowest valley. So the highest peak is going to be up here. This is our absolute maximum. And when we look at the graph, where's the minimum? Looks like over here is the absolute minimum. So let's write down those coordinates. Absolute max is a -10, 6. Absolute minimum. And again, these are coordinates, so these are parentheses, no square brackets. That x value is, say, -1, -2, 3, 4, 5, 6, 7, -7. And I believe that's a -6. 1, 2, 3, 4, 5, 6. Yep, -6. Oh, we forgot letter D. Okay, so D, state one interval where g of x is greater than 0. It's greater than 0 in a lot of intervals. It's greater than 0 here. It's greater than 0 throughout this entire S-curve. And then it's greater than 0 in that little piece right there. So basically what letter D is saying, pick one of those intervals where g of x is greater than 0. I can say that it is positive from negative 10 to about negative 9. I could say that. I could say it's negative 1, 2, 3, 4, 5, 6. It's not quite at 6. Maybe negative 5.9 all the way. 1, 2, 3, 4, 5, 6, 7. It's like a 7.2 or 7.3. And then it's positive again, 7, 8, 9. Looks like 9.8 to 10. It's positive again. So any of those intervals would work. I could even chop it up and have them smaller intervals. But again, any of those intervals would work for that question. State one interval where g of x is greater than 0. What's the range of this function? And from the previous question, or a couple of questions ago, we look at the y values of our absolute minimum and absolute maximum. That's going to help us with the range also. The lowest y value is going to be the negative 6, and the highest y value is the positive 6. Explain why the graph above represents a function. It's a function because, and I know you want to say because it passes the vertical line test. The vertical line test is just a test that we use to determine if a relation is a function. The reason it is a function is because there are no repeating x values. Each x has only one y value. And it does pass the vertical line test. So you want to be careful that there are no repeating x values. Each x has only one y value. And that way it is a function because it passes the vertical line test. How many intervals in this function are, and in how many intervals is this function decreasing? State one such interval. Let's go back at our graph and erase what we have. So I can highlight where are we decreasing. We are decreasing here. We're decreasing there, there, and there. There's 4 of them. There are 4 intervals where this function is decreasing. And we can pick. We can pick either any of those intervals. The easiest one probably to pick is the first one from negative 10 to negative 7. It's decreasing. All the other ones look like we have to use some sort of decimals, but that's okay. All right. Down at the bottom, here's another type of question that you're going to have to know how to do. We're going to be comparing 3 functions, but they're written 3 different ways. Letter A is given to us as an equation. Letter B is given to us as a picture of a graph. And letter C, our function, is given to us with a table of values. And we have to compare their minimums. Well, what does the graph in letter A look like? We know it's the absolute value, so it's a V graph. Next class, we'll talk about what x minus 4 is. To the right 4, and the minus 6 is down 6. So we have a V that looks like this. Negative 6 is its minimum. For letter B, it's a little bit easier. You just have to count the boxes and notice that negative 4 is its minimum. And in letter C, look at the y values here and notice that negative 8 is the minimum there. Comparing all 3 of those, which one has the lowest y value? And that would be letter C, choice C. All right, one more thing that we have to be able to do when it comes to terms of functions is to be able to sketch them. So it's kind of the opposite. This time all the information is given to us and we have to sketch the function by putting all these pieces together. For the first one, number 7, says domain will be all real numbers and the range all real numbers. This gives us a clue that we will have arrow tips. Where and if we're going to have them both of them, we don't know. We have to look at the other information, but we definitely know for sure that one of them, whether it's going to be going up, down, left, or right, we're going to have some arrow tips there. There are two zeros. We have a 0 at 0, and we have a 0 at 4. 1, 2, 3, 4. And because f of x is odd, if I know that 4, 0 is on the graph, what's the other point that is the reflection through the origin? What do? We negate both the x and the y. So point -4, 0 is also on the graph because we're told that our function is odd. 1, 2, 3, -4. That helps us out. Let's see what else. Right to end behavior, y is decreasing, so we're going to have an arrow tip going down here. Somewhere in there, when we're done, that arrow tip is going to be going down there. It is decreasing from -infinity to -2. Okay, so we'll kind of keep that in mind where we're starting to put our pieces together. And then there's a relative minimum from at -2, -3. So -2, -3, there's a minimum. And again, because the fact that it's odd, what other point is also on this graph? We're going to negate -2, -3 to get to 3. All right, I think we're ready to try to draw the graph. And the fact that f of x is decreasing from -infinity, now it makes sense that it's going to be decreasing. So we have our graph coming up from the top, hit our relative minimum, cross our x equals 0, hit our +2, +3, which happens to be a relative maximum, comes back down, and we can attach it to our end behavior of -infinity. And there's our graph, putting it all together. We didn't do it in order. We picked out the ones that helped us out first, and then we filled in the blanks with the ones that we didn't use. Let's try it again one more time, the one on the bottom. Again, we're given some information about this, and we're going to put the pieces together to create a graph. G of x is even. Okay, we know it has symmetry over the y-axis. We'll keep that in mind when we need to plot some points. G of x is below the x-axis for the interval 6 to infinity. So after 1, 2, 3, 4, 5, 6, it is negative, so it looks like it's going to be going down. We know that at g of 6, y is equal to 0. Okay, that makes sense because then the graph is going to go down. And then again, let's go back to the fact that it's even. If 6, 0 is on the graph, what's going to be the other point that is on the graph if it's even, if it's symmetric over the y-axis? It will be the point -6, 0. 1, 2, 3, 4, 5, -6. Y-intercept is 4. Plot the point of y is equal to 4. And then let's look and see, we have g of x is constant for the interval from -2 to 2. So from -2 to 2, it's the same y value. And we already know that at 0, the y value is 4. So what do you think is happening from -2 to 2? Hopefully you're drawing a horizontal line at y is equal to 4 from -2 to 2. Because we know that at 0, the y is equal to 4, and it's constant from -2 to 2, so it's constant at y is equal to 4. Last thing that is given to us, g of x is increasing for the interval from -6 to -2. So from -6 to -2, it's increasing. Now I have to fill in the blanks here. Knowing that it's even, this left side here, from -6 to 0 has to be reflected, so that means from +2 to +6. It's going to be decreasing. This is a reflection. We were told that it is negative. It's below the x-axis from 6 to infinity, so it's going down. Try to make that a little bit more linear. Doesn't have to be, but maybe it makes it a little bit more. Continue that line. And again, because it's even, this arrow that I just drew, we're going to reflect it over the y-axis and draw its reflection on the other side. And I think that's it. I think that's as much as we can do for our graph. Now these graphs may vary a little bit, but for the most part, we should be getting the same sketches. Last question, the point 6, -2 lies in the graph of h of x. Name another point on the graph if h of x is odd. H of x is odd, both x and y get negated. So -6, +2. If h of x is even, only the x value gets negated because we flip it over, and the y value stays the same, -6 comma -2. Okay. Like I said in the beginning, these are the day 5 notes. If you do have questions, please make sure that you come in, help each other out, and I will see you next class. Thanks.